Okay, let's start. Yeah, thank you for everyone joining us today. Mina's workshop session. I am Kinjo, founder of Akindo, which organizes WaveHack Global. So I'm super excited to onboarding you guys to the Mina's technology, which grant partner us. And so yeah, so first our members Moz. Moz today is folks out there. Yeah, Moz first explain what about WebHack Global, and after that, yeah, today's Mina's members John explains yeah, Mina's technology. Okay, first of all, so please Moz explain WebHack Global.
Yeah, thank you for the introduction, Sam. I'm Moz from Akindo, and really excited to be here for today session. And let's get started. Right. So first of all, welcome everyone to our WaveHack Global Onboarding Workshop. It's a pleasure to have you with us today. And yeah, I'm excited to introduce you to this acceleration program designed to foster the next generation of groundbreaking crypto applications. WaveHack Global is a prize-funded acceleration program that aims to support builders like you in bringing your innovative products to market. With the backing of our top-tier partners, we provide grants and feedback to help enhance your solutions, whether you're launching a new project or expanding an existing project. The program is already underway, and we gear up for 3 major demo days in Japan this summer. Let's explore why WaveHack Global is the event you don't want to miss. You'll have opportunity to receive grants from leading global projects like Mina, zkSync, Manta, The Graph, Aptos, XRP Razor, and more. Every 2 weeks, you receive valuable feedback from expert judges of this project, and our weekly online study session will keep you updated on the latest technologies and in-demand products. Additionally, you will have a crypto conference in Japan, including AI+Crypto, EdoCon, and WebEx. Yeah. And WaveHack Global is an accelerating program, opens to all builders, whether teams or individuals, at any time, and free of charge. This summer, you have the opportunity to impress a broad audience with your projects tailored to our grant partners' themes and contribute to the mass adoption of crypto. So today, we are thrilled to have John from Mina Protocol leading this workshop. Mina is the world's lightest blockchain powered by its participants. In this engaging session, John will explore how Mina can be a foundational tool for zk proofs. He'll introduce the features of the Mina Protokit with examples, make it easier for you to build zk-powered applications. We'll also have a live Q&A session at the end, and you can ask Jan anything about Mina or your projects. So feel free to comment on YouTube throughout the sessions, and we'll address as many questions as possible. So please note that Mina build theme at WaveHack Global is build consumer zk application using O1.js. Here's very important O1.js because it's a key criteria for this program. So our protocol framework, which includes 10,000 grants. This theme challenges you to offer practical utility using Mina's zero-knowledge proofs for consumer zk apps. So zero-knowledge proofs offer both privacy and verifiability on chain. So get creative in exploring value creation. So it's a great opportunity to contribute to the Mina ecosystem, showcase your technical skills, and present innovative ideas. Currently, it's as you can see, it's a second wave for this scene, and we are excited to see what you build and how you leverage Mina to push the boundaries of what's possible in the blockchain space. All right, now, without further ado, let's welcome Jean to share his insight and expertise.
All
So,
right, so stage is mine,
yeah,
I think.
yeah,
All right,
I'm
let me
good.
share my screen.
Yeah, let me stop the sharing.
Okay, so is everything okay? Can you see my screen actually?
Yeah, you can see.
All right, so let's start. Actually, thank you for the audience for coming up today and actually getting information on Mina protocol. And let's quickly start. So we're going to be talking about Mina protocol and Proto-kit framework built on top of Mina protocol as well today. And we will see some examples of how we can actually implement our on-chain functionalities in Proto-kit. So Mina protocol, as it has been stated in this live stream as well, it is a lightweight blockchain with constant size. And that is actually, Mina protocol is powered by zkApplications for scalability and decentralization. So scalability and constant size are very, very important key features we will be talking about in this slide, because Web3 applications need to be fast. They need power. They need these things. And we can ask the question, what is Mina? Of course, you can actually Google it. But why Mina is a much more important question in terms of Mina, because Mina has a minimal blockchain size and a consistent performance thanks to a technology called zkApplications, which are actually allowing data to be compressed to the small proofs. So you can imagine it like I have a book and I'm reading a book and I'm telling you that I'm at the 10th page of the book, and you're saying that I'm not believing it to you. I just want to see that you're at the 10th page, so prove it to me. And I'm showing the book to you, but I'm closing the part that is including the content. I'm just showing you the page number. So this is a very basic example of proofs at the Web3 space, or proofs in general. So this is actually known as succinct, non-interactive arguments of knowledge. I'm not showing you the whole data, I'm just showing you the proof. And that is enabling Mina to be really, really light. And it is actually allowing protocol to be ideal for applications requiring high throughput and scalability, such as Web3 games and the apps that are requiring that. So power, unlimited power. We talked about zkApplications, which is standing for zero knowledge, succinct, non-interactive arguments of knowledge. But the thing is that this enables Mina to maintain a constant size of blockchain, which is roughly 22 kilobytes in size. And this is making Mina protocol one of the world's lightest blockchains, and it is very, very powerful. And you can use Mina for actually wide range of possibilities for developers and users, including decentralized applications, financial services, maybe Web3 applications, Web3 games. These are all possible in Mina. And what if I told you that you can increase your speed in Mina with a framework called Protokit? Yeah, of course. In the description, you can see that the framework enabling developers to build zero knowledge, privacy preserving applications with a minimal learning curve. And with a minimal learning curve part is very important, because Protokit is very easy to understand, very easy to learn. You will see it in the examples. But the thing is that Protokit is actually very, very useful if you're trying to build something which is fast, which is scalable, which is easy to implement, and we will see it in a bit detail. So first of all, let me tell you that in Protokit, you're building an app chain for yourself. So you're creating an app chain, and that app chain can be actually connected to Mina protocol. So this way, actually, you can still have on-chain functionality implemented on top of Mina, but faster. We will see it in a detail. So let's talk about Protokit's key features first. So it is very, very important that we are constructing privacy-enabled application chains with that framework. And as we stated before, crafting zero-knowledge, privacy-preserving applications was the main target when Protokit started. So it is powered by O1.js, as we stated before, but it is a very, very easy way to implement your own on-chain functionality. And O1.js is the SDK dedicated to building zk apps on Mina. Protokit ensures seamless compatibility with the Mina blockchain. As I have stated before, if you're writing Protokit code, that means that it will be seamlessly compatible with the Mina blockchain, and all code authored within its framework is provable. So proving is actually very important in terms of zero-knowledge proofs. And Protokit's key concepts. So in here, you can see that there are three distinct layers in Protokit. So these are very, very important fundamentals of the Protokit: runtime, protocol, and sequencer. This is the architecture of the Protokit. But the thing is that heavy lifting is being done by the Protokit. So you don't have to worry about what am I going to do. If you just want to implement your on-chain functionality with the Protokit, you can use runtime modules, runtime methods, which we will see in a little bit more detail in upcoming minutes. But the thing is that if you don't want to worry about it, you don't have to, for example, just work on the protocol too much. You don't have to just work too much on the sequencer a lot. For example, Protokit has a starter kit, and you can actually reach everything related to the Protokit from GitHub page. These are all open source things, framework, examples, and things like that. You can go there, you can check the example codes. And in the starter kit, for example, there is a sequencer which is very powerful. Basically, sequencer is accepting the user transactions and orchestrating them. Protocol is for the state things and state-related things. And runtime is the business logic. So when a user interacts, what we want to do will be actually written in the runtime, and then we will be actually worrying about runtime most of the time at the Protokit if you are not trying to implement something very, very detailed. So Protokit is very easy to learn, thanks to, of course, it is a TypeScript-based framework. It uses custom tailored zkVM. It is having a hybrid execution model, so both off-chain and on-chain. End-to-end proven execution is also supported in Protokit. Customizable and modularity is one of the key features of the Protokit, and very, very powerful. And you can build zero-knowledge, interoperable and privacy-preserving application chains in Protokit. So appchain term is very important. So what you try to do is you're creating your appchain that is iterating the logic on it, and you are actually verifying and proving that the things that are being done at your appchain is actually provable, it's on-chain. So what you do in Protokit is not, as we stated in here, they are all actually seamlessly compatible with the Mina blockchain. So do not think that if I'm writing on Protokit, there will be some misunderstanding, there will be some problems. No, Protokit is a very, very easy, very, very fast, and very, very powerful framework. So we have reusable modules, and most importantly, we have no data race conditions thanks to sequence transactions. So sequencer is a very, very important component in here. And bottomless on-chain data storage is also supported, and preserved privacy, as we have stated in the description of the Protokit. The main concept was actually privacy-preserving app-chain development. And you only have to focus on business logic, as I have stated in the slides. So heavy lifting is done by the Protokit and integrated with user wallets that are supported on Mina ecosystem. So you don't have to worry about it at all. And iterating your on-chain logic is faster than with the layer one. So layer one is the Mina in here. So your logic will be actually executed even faster than Mina, and which is a mind-blowing thing. And of course, there is the Protokit architecture, and we talked about it: runtime, protocol, and sequencer. You can see that protocol is underlying state machine and block production circuits, and sequencer is the orchestrates runtime and protocol, handles the block production pipeline, mempool, and more, and things like that. So we will not go into detail of the protocol and sequencer because most of the time you will be working in the runtime. So let's start with the Protokit examples on the runtime. It is very easy. Let's start to understand what it is and what we can do within the runtime. So defining a runtime model. First of all, let's talk about how we can describe our runtime. So runtime is like the shell that is storing the runtime methods. And runtime methods are like, for example, you want to do something on the app chain, you are interacting with a runtime method. That's basically a function you're writing and you're describing it as a runtime method, and users can interact with these runtime methods with a transaction we will see. So basically, what you do is you're creating a basic runtime module with add runtime module, and you're just describing it as export class example that is inheriting the runtime module of the Proto-kit frameworks libraries. And you're writing the stuff that are actually for example, runtime methods, states, and things like that. We will talk about it. Let's talk about how we can add the business logic of our application. For example, let's give a very, very simple example. We want to store how many times the users are interacting with our app chain, so we can write a basic runtime method, and we can actually increase the number of interaction count by 1 each time a user interacts with our runtime method. And we will see it in a little bit more detail. So in here, we have the runtime method with appruntime method. You can see that it is very easy to describe it as well. And we are defining a basic function with public increase number. And it is time to actually talk about, yeah, of course, we have runtimes, runtime modules, runtime methods, but how we can store data inside of the Protokit. Well, it is also very, very simple. So you can see in here that this is a state which is holding an unsigned integer value. So state can be used to define variables which will be stored inside appchain. That is a very important K concept or K feature in Protokit. Basically, it is very easy. You're defining it at state, public interaction count. I just gave an example that we will try to track the number of times that the user interacted with our runtime method, so we can actually implement this. So let's try to implement it and let's try to learn what we can use for that purpose. And public interaction count is equal to state from, this is very important. We will talk about it in a little bit more detail. So we are using unsigned integer 64, which is basically unsigned integer in 64 bits. And basically we're saying that I want to store a value that is unsigned integer inside of that state, and this will be called as interaction count. But how we will actually access to that data, basically we can actually define a constant variable that is called some interaction count, and we can set this with using this keyword, this.interaction count.get. So we are getting the state, but then we need to reach the value of its value that is stored inside of that state. So basically, we're adding value. And right now, our constant interaction count is holding the unsigned integer value inside of our runtime method. But this is, for example, and we are not still increasing the interaction count by 1. So let's try to do that. So of course, we can increase it, but then we have to store that data inside of our actual state. So in order to do that, we will use a function called set that is actually defined in the state. So these quotes, as you can see, we are going with the same quotes. So I'll just explain these 2 lines at the bottom. These are all same things. So we can increment interaction count by 1. As I have stated in the before, unsigned integer 64 in Protokit is different from O1.js. So that's why you have to say that unsigned integer 64 from old interaction count. Basically, we're saying that get the old interaction count and give me the form of unsigned integer 64. And basically, we can get the unsigned integer 64 from old interaction count. This is giving us the unsigned integer of the old interaction count. And you can see it in here that if I write only 1 without unsigned integer 64 form, it will be TypeScript 1. So it will not be actually a common, or it will give us an error, and it will say that you have to use the Protokit's variable, and you can check the documents for explanation. That's why I'm converting them and I'm adding them to each other to be saved in a variable that is a constant new interaction count. And then basically I'm calling the set with actually calling the state, using the set, and setting the new interaction count. You can see that it is a very, very easy thing to use in the Protokit. And with this, each time a user's call increase number function, interaction count is increased by 1. So, but I mean, that's a very easy thing to do. But what if we want to store interaction count separate for each user? For example, user A visited 5 times, user B interacted 3 times. Maybe it is very simple for you, but of course, this is the workshop's thing to do. We're trying to understand the key concepts with the basic information available. So you can extend these structures. You can implement your own on-chain logic inside Protokit with that easy concept. So in order to do that, we can use something called state map that can be used to store map data. It is not a dictionary, but it is similar to dictionary. You are actually saving the data, for example, a value with a key. So for example, we can use, well, in blockchain and Web3 space, we know that wallet addresses, public wallet addresses, are the identity of each user. So why don't we just save the public key, as you can see in here? I'll explain it a little bit detailed, but in here, you can see that we are mapping the data with the public key and the interaction count of the user. So basically, we are still using the same syntax at states. Public interaction counts is equal to state map. We're using states map instead of state from public key unsigned integer 64, and we're defining it what will be actually the inside. So we will use a key for public key, and then we will store an unsigned integer value inside of that state map. So let's try to change our code for storing the k mapped values. So in order to do it, you can see that in order to get the user address, we can use this transaction.sender.value, which will give us the user that is interacting with the runtime method. With this way, we will know that which user is actually trying to do something. We will talk about it in a little bit more detail in the upcoming slides. So we are getting the wallet address of the user. Then we are actually getting the user interaction count. But there is a very important, simple difference in here. Instead of not giving anything, right now we have to give a key because there are multiple values and we have to describe which value we are trying to get. Of course, we want to get the user addresses value. So we can give the key as it is seen in here. This is the same code. There is no actually difference in this line. But in this line, you can see that in the set, we are giving the interaction count, mean interaction count, as a second parameter. As the first parameter, we are giving in which key we want to store this value. So this is basically using state and storing data in Protokit. But what if we want to make it much more advanced and we want to say that I just don't want to save a single value? For example, a user, let's talk about a Web3 game. A user will have, a player, for example, will have XP level and things like that. Or maybe we're talking about a SocialFi application. A user will have followers. A user will have photos shared. There are so many variables inside. These are all examples. That might be dumb, but these are all examples. So we can actually use user interaction entity, for example. This is an example definition, so you can change the class name. We can use struct, which is actually inherited from O1.js. So you have to import struct from O1.js. And structs are very, very powerful. And you can use this struct to, for example, store interaction counts, unsigned integer 64 value. Then you can use some other variable inside with unsigned integer 64. And defining it is a very, very easy process, as you can see in here. And then in the runtime module, instead of saying unsigned integer, we can give the user interaction entity we created in here as a value. And when we call this public case value, we will get a user interaction entity, and we can actually pick which value we want to use. So actually storing complex map data, we can see that state map can be combined with structs to hold much more data together mapped on a chain. So basically, you can see that this is the same, but in the second line, we are getting the value. And after that, of course, we have a little bit complex data, much more data in that entity. So we have to define the which value we want to get. And basically, we're saying that I want to get the interaction count of this entity. So we are saying that value, but interaction count. And then I'm using the add operation in here. It is as same as it is. But when we set the value, we're giving the K, but then we're creating a new user interaction entity, and we are giving the interaction count. You can see that I'm still using the unsigned integer 64 from here, and I'm setting the other variable, which is unsigned integer 64 from 0. So basically, this is how you can set an entity. And you now know how to store the complex map data. So why don't we just do some classics? So this is, in most of the workshops, you can see that, but let me just get a little motor. It's a very consuming my power, whatever. So let's do some classics. We want to actually implement a functionality that there are some balances on appchain, and you know that 99% of the appchains are having balances or tokens inside so people can use it. And in this example, what we want to do is we want to write a transfer runtime method so that, let's say there are two persons, Alice and Bob, and we want to make sure that Alice can send some balance to the Bob. So in order to implement it, we're getting some arguments in here, as you can see. So from public key to public key, and the amount that we want to send. And these all on unsigned integer form. And you can see that we are using a basic state map with public key, Kate, and unsigned integer map. So that's it. So we're getting the from balance. So how can we get the from balance? We're sending to someone. We can get it with who is sending that. We can get it with the using K and getting the value. We can use to balance. And after getting views, there is an important feature. We can see it in here. So we are trying to get a condition. So we're trying to check a condition. So I'm sending someone 100 tokens or balance, but I don't have that much. I have 80 balance. So in order to send it, I should at least have 100 tokens or balance to send someone else. So in order to do it, of course, we can check that the player or the user is not sending an amount that the user doesn't have. So in order to check it, we can use greater than or equal. These are very, very simple things, and you can just check them. They're very easy to use. And this is returning as a Boolean. And we can say that the amount that I want to send, if it is actually higher than the balance that I have, it will return false. Sorry. Let me get a word. All right. If it is actually higher than that, we're going to use assert. And assert is very, very, very powerful. And I'm just giving this Boolean value. And I'm saying that if it is actually higher than my balance, I'm saying that from balance is insufficient to transfer. But there is a problem in here. I can use that transfer method, even though I don't have the ownership of the account, I can use it. Well, then we can assert it with just checking that if from value is the same with this transaction sender value. And if it is not, we're going to say that you're not the owner of the from account, so you cannot send it. Well, this is not a good approach of implementing it, but in order to show that authorization can be handled, this is implemented like that. So we are then defining the new from balance with subtracting it. We actually talked about these a lot, and we're setting the balances. That's the basic explanation. So let's talk about it. And another cool feature, giving proofs as arguments. So we can give proofs as arguments, but before actually giving the proof, we have to define the proof in the code so that it can be given as an argument. So I'm just writing a dummy proof that always returns true. So const can means it is returning true. In reality, it's not like that. It is returning either true or false or things like that. But in here, we're just using it for experimental purposes. And then I'm defining a can-mint program, which is an experimental zk program. And I'm giving public output, public inputs, and methods. And you can see that I am giving the can-mint method in here so that it can be used in the can-mint program. So let's give it as an example. So in class can-mint proof, we are actually inheriting it from experimental zk proof with giving the can-mint program that we have, that we defined in here. And after that, we have the proof class. And we can define the proof in here. As you can see, we are actually defining Pickle's proof of base 64 in here. Then we are defining the public input in here, which is a field that is actually from 0. And then we are defining the proof with new can-mint proof. As you can see, we're giving dummy as the proof. We're giving public output, public input, and max proofs verified as parameters. So later than that, we can actually give the proofs as arguments as it can be seen. We have defined it. So imagine that it is defined in the code. Then we can actually give it as a proof argument. So can-mint proof can be given as an argument that we're giving some amount. So mint is a very, very classical method. You will see it on many of the blockchains. Basically, you can mint if you have whitelist. So for example, you can use this for, let's say, you're saying that I am eligible to claim some tokens, claim some NFTs. I am described as a whitelisted person. But if you're not whitelisted, how can we check it if you're able or not able to mint it? So you can generate a proof and send it to the runtime module, runtime method, and runtime method will say that, okay, you're eligible to do that, and or you're not eligible to actually mint this. So you can actually verify it in here. For example, you're actually distributing some NFTs, and you're saying that this guy is not whitelisted. So the proof that we wrote in here, dummy one, will return false. And we will say that this guy is not whitelisted, and we will not give any NFTs to this guy. So if it is actually eligible, then we can, for example, in here, we are giving some balances to the user if it is eligible. But this is also a wrong, I mean, it's an example implementation for showcasing. In this here, for example, I can write that 5 million balances and add it to myself. Of course, there has to be some control mechanisms like how much that a user can get or things like that. So example Proto-kit test. Yes. So how we're going to test it? I mean, if you try to write the runtime and if you try to write client interactions and things like that, and if you try to test it this way, you will lose a lot of time. But if you write minimal tests that test the functionality that you wrote, the business logic you wrote in Proto-kit, it will be very, very easy to do. So you can define example tests, and let's try. As you remember, we actually were storing the user's interaction count with storing complex map data in here. Let me just show it to you. We have this. Remember, we have this functionality. We were saving this user interaction entity. So basically, we were increasing the user interaction count by 1. Let's try to test this functionality. So how we can test it? Well, in Proto-kit tests, first of all, we have to, inside of the test, this is an app chain. So basically, we have to start the app chain first, because app chain is, as I have stated before, there is a different architecture. There is runtime protocol and sequencer and things like that. Inside of your test, you have to start the appchain, but first you have to define it. And you have to give the example runtime module, which is described in here, as an argument to the appchain, so that our runtime is consisting example runtime module. And it will be running. And then we can configure partially. So you can see it's that we are giving something in here, so we didn't give anything, so we will not give any starting value or configuration for that right now. Then we can start appchain. Imagine that the first calls are in here, and we are starting the appchain. We are generating a random private key for our purposes. Then we are saying that this is the private key of the Alice. We're getting the public key of the Alice, and we're setting the signer as Alice private key because we want to make operations on Alice. And then we're getting the example runtime method with appchain runtime result. So you can see that it is very easy to write the test. From that point, you can start testing it, and that's all easy to configure. So later than that, I'm going to call example increase number, but this is a transaction. So I'm defining the start transaction in here with giving the Alice as the one who is interacting with that transaction or runtime methods. Then we're signing it, sending it, and producing the block. So in order for you to see the changes in your app chain, you have to wait for a sequencer to produce the block. And after block is produced, you can actually check the data if it is changed or not. That's why we're going to actually wait for block to be true. And if it is actually true, we will test the interaction count. You can see that we're sending it. We're actually getting with a query the interaction count.get. This is very similar to what we wrote in the runtime method or runtime modules. Then we are getting the interaction count with a promise. And after that, we are expecting interaction count to actually that is converted to begins to be 2. So for example, at first, I think it was 1, or we give 0. It matters on your runtime module. If you give 1, then it will be 2 because we actually interacted with the runtime method. So that's all for the Protokit and Mina. I hope that you enjoyed, and thank you very much for listening to that part. Yeah.
Right. Thank you for your session. It was all inclusive explanation. It will definitely help all builders, and especially how to use Protokit for using O1JS. All right. We got some questions in the YouTube comment. Let's jump in and let's see what you guys want to know. Okay. The first question was, could you please share this slide with us at the later date? Could you actually, yeah, definitely we can share this slide. You can come to our Discord later, and we will post it on the Discord. So yeah, if you guys have any question, please feel free to ask. All right, it comes, from Jared Lim. What's some possible project ideas to build on Mina?
Well, I can explain it in a bit details since I am also a navigator at Mina Protocol, and I've seen that a ton of projects which are actually, there are so many talented people in Mina. And I can say that, for example, I was developing a Web3 on-chain game. So, for example, you can develop a Web3-based game. Really, that is actually working on that because in Protokit, for example, in each 5 seconds, you can produce a block, which is default by the sequencer. But if you have actually a powerful machine, maybe you can produce the blocks in a much more faster way. So, for example, you can develop a fully on-chain Web3 game in Mina. You can produce the apps. For example, one of my close friends are building a rollup for actually a DApp service, and it is also very fast. So you can implement anything on Mina with the help of the Protokit, of course. You can build anything you're dreaming of. So basically, if you need high throughput, Mina is the right choice for you. If you, by the way, that's also very important. You can store off-chain data, on-chain data on a centralized server, and no one can actually change that data because actually it's rooted with Merkle trees So if the product owner tries to change the on-chain data, then it will be corrupted, so it will not be usable. So that's very easy. So if you are actually familiar with the blockchain, the most important issue, or in games, maybe the apps, maybe other places, the data storage is very big problem. One of the most important problems for Ethereum was that, and there has to be an update to actually bring data storage to the layer 2s. But in Mina, you don't have to worry about it. And also, Yasin gave a great question, a great idea, focusing private user data. And he says that imagine an Uber app that allows you to give rates as an anonym. That's right. That's right. So, for example, you can write an application and you want to make a voting. You want to make sure that the voting is being done by the people that are eligible to vote, but you don't want to actually share their identities. So with that way, you can use proof to prove that that guy is eligible, but you can also not cover the identity of that user. So there are a couple of things. And if you join to the Mina Discord, you can see the Navigator projects, zkIgnite projects. And the most important thing I think Mina did was actually allowing these projects to be open source. So you can actually get all of the codes from GitHubs of these projects.
Right. Thank you for answering, and it's interesting. Yeah, it's a great insight. So if anyone has other question, you can pause in the comment. And I actually have one question. Yeah, it's pretty newbie for zkP. So like I've used some other framework before, and I would like to know what's the difference between the zkP framework, like such as Circom, or like an O1JS, or as well like there was Snark.js. Yeah, I haven't distinguished between them yet. So if you can explain that, yeah, it would be
Right.
helpful.
So first of all, Protokit is very easy. The main thing that the people are choosing Protokit is because it is very easy and well documented. So as I have described it to you, so if you are like producing a medium-based DApp or app chain, you will not need that much except from the workshop that we made. That's the power of the Protokit. I mean, you can use simple things, simple lines of code, and Protokit will handle the rest things for you. You don't have to write a sequencer, you don't have to write a protocol, and with just only writing runtime, you will have the power to deploy your own app chain, which is very powerful. And apart from O1JS, to be fair, I'm gonna give an information from me. I was using O1JS in my project, and I think I was writing 2K lines of code for a functionality. And in runtime module of the Proto-kit, I wrote only like 100 lines of code. So I decreased the number of lines of code that I wrote by 20 times. So that's a huge thing. And I didn't have to like look at the documents too much, look at the things too much. The most important thing about Protokit is it is very fast. You're not storing on-chain data. And with the sequencer support, you can reach to that data with proving it. And also, Yasin is also mentioning about some important features. Also, key difference is using Circum for you build etc. applications on Ethereum and the state grows always. That's exactly right. And on Mina, everything is only one proof and they are recursive. So that's why Mina is 22 kilobytes. I mean, it's a very, very mind-blowing thing that Mina is only 22 kilobytes. And so you can run unlimited computation and create a proof on it, which makes the true distributed computer. Ethereum is decentralized, but not really distributed. So this was Yasin's actually thoughts, and I shared my information on that. I mean, if you're interested on Mina, you should actually, not thinking about what I can build. Instead, you can say that I want to build that so you can jump to the Mina. So everything is possible in Mina thanks to a huge throughput. I'm saying that you can perform actions that a sequencer is running in each 5 seconds, and you can prove them. And they will be actually provable on Mina as well in each 5 seconds. That's a mind-blowing thing, by the way. That's a very, very mind-blowing thing. So it will be really fast with a huge throughput, and you will be able to actually build something that is just similar to a Web2 application. So I would recommend looking at Protokit and O1JS as well, but I'm a Protokit fan, by the way. So I would choose Protokit.
I see. It's very informative, and it's good to know like how it's different as well. Yeah, and definitely it helps builders a lot for this information. And as well, for example, if you find out a great product through this WaveHack Global, do you think how do you support and how do you how you're gonna support for the later on for this project? Yeah.
I think that's something Yasin should answer because he's from Mina Foundation and I'm just an navigator. So, but I can talk about. Okay.
Should I? Do people hear me, or should I answer written?
Okay. Yeah, we can hear you.
Okay.
Yeah, we can hear you.
Nice. So the question was how the Mina Foundation supports builders if they continue building, right? Did I understand it correctly? Okay. So first of all, we have two big grant programs, which is called zk Ignite and Navigators. And actually, this 10th of May, we will announce the new version of Mina Navigators. And if you go to Mina Protocol Discord itself, you will see a Navigators information call on 10th May. But the whole idea is we have been designing our grant programs with connecting with them each other. What I mean is like you will have a starter grant that is for a month long of work, and then you can apply for 3 months of work, and then you can apply for bigger grants. So the whole idea is right now we really have the resources for developers who is interested in to invest their time, like start building a proof of concept and then deliver a real product. So I would say we really focused on growing in Japan and Asia as well. And like right now we have navigators and zkNet programs, which really fits in different scopes of products. Hope my answer was helpful.
Yeah, thank you for your answer. It's actually we are honored to build developer community in Japan with you, Mina, and we are excited to see what we will see later on. And plus like other question for me, sort of ask a lot. Is there like some example that you've seen as a like great product through like a grant program or something? For the hackathon, something that you've seen before for within your event.
Yeah, great. So great question. Maybe I can let me open my camera. So I can give the example from healthcare. So like the health data is very sensitive, right? And like a month ago or something, we were in East Seoul in Korea, and one team built a private DNA zk app. If you heard about like there are products where you give your DNA and make analysis, right? But like your DNA and your health data is very important and sensitive. And what they built using Protokit was really actually you keep your DNA and geneal sequencing data private, but instead using proofs, you have outputs of like analysis of DNA or old healthcare data. So I will definitely say like healthcare industry is a great example of or like where to build zk apps. And the example was these DNA sequencing and gens analysis products are a great example of where you can build a zk app where you need the privacy, right? Yeah.
Yeah, I see. That's interesting. Yeah, it's true. Like people don't want to show or like be seen their information, and as well like there was privacy there. So it's
Yeah.
definitely zkP is one of the solution to solve this.
Yeah.
Yeah.
I will really highlight two mental models like for Mina developers. Which one is really like privacy, private user data? So you can think just not blockchains, like zero knowledge and Mina is more than blockchain actually, because it works with proofs. Like you only have one proofs and you can use Mina everywhere. So that's why I will really motivate people to think about where we really need privacy most. And that's a good thought exercise. And another mental model is really unlimited computation. So because Mina is just one proof. Like Mina is always one proof that proves all the computation backwards. So what means is like you can run computation on your own computer and just create proofs on it. So which means like you have limitless computation, and which makes Mina the distributed computer where you can run multiple computations all over the world, all right, with different machines. So I will really motivate people to, you know, understand more about where we need privacy and also how distributed computer really works and how they can contribute to it. Yeah.
I see. Yeah, it's if the information need to be hide and be hidden, probably like this kind of information is for zkP. And if you know that in this world there is a lot of things that we cannot show, or like we need to hide, like for the privacy. Yeah, this kind of information probably like the way to go with Mina and Protokit. Yeah. By
Exactly.
the way, don't worry. Yeah, if you miss some parts of this online session, this session is being recorded and will be published immediately after the live stream, so everyone can watch again. Yeah, and let's see if
By
we
the way,
have.
I also want to mention about a very, very important information. If you are actually interested on developing something, but if you don't want to kickstart it from start, from Protokit, there is a starter kit called a Protokit GitHub repository. So you can go to the GitHub page of the Protokit, and from this Protokit starter kit, you can actually see that you have a simple working app chain with a sequencer protocol and runtime working, and you can kickstart your application from that point, which is very, very easy. And also, if you actually search Protokit on GitHub, thanks to the Navigators program, there are so many projects using Protokit on their on-chain functionalities. And you can basically get their runtime and plug and play of your actually runtime, which will be very, very helpful for you to develop your app chain very fastly and very, very efficiently, actually. So you can use Protokit starter kits, and it's a very powerful thing to do.
All right, that's informative. Yeah, thank you very much. So I think that's all the question we had for today. All right. So it was a fantastic session today. A big thank you to everyone for your active participation. And special thanks to Jan and Yasin for sharing such an insightful presentation and for answering all questions. It was truly a valuable learning experience for everyone. As we wrap up, let's keep the momentum going. The build theme we discussed offers a fantastic opportunity to explore the possibility of Mina. Be aware that it's very important to use O1JS. Probably the easiest way to use O1JS is using Protokit. And because it's a crucial criteria for this program. And also, don't forget this WaveHack Global program is not only a chance to win a grant, but also an opportunity to contribute to a growing community. For ongoing resources and support as you build your project, keep an eye on the Luma page and stay tuned for upcoming sessions. We are here to help And if you have any questions or need further guidance, don't hesitate to reach out throughout our official channels such as X and Discord. Thank you once again for joining us today. We look forward to seeing you at our next session and can't wait to see what you build. All right. Have a great day, everyone. Let's keep building.
Yeah, let's keep reading. Thank you for participant. And thank you
Bye,
for,
everyone.
yeah,
Thanks everyone. Thanks.
thank you.
Thank you.